Have you ever wondered what it would be like to journey to the Earth's core? A voyage that takes you through layers of our planet that are as alien as any extraterrestrial landscape. This is not just the stuff of science fiction, but a real scientific curiosity. Beneath the ground we walk on, there is a world that is as mysterious and fascinating as any on the surface. Our planet's core is a realm that remains largely unexplored, a place that is hotter than the surface of the sun, and where pressures are millions of times greater than at sea level. It's a journey that would take us through the crust, the mantle, and the outer and inner cores, each with their unique characteristics and secrets. Understanding the Earth's core isn't just about satisfying our curiosity, it's about unlocking the secrets of our planet's magnetic field, its geothermal energy, and its very formation. So, are you ready to dig deep into the Earth's core with us? It's going to be a thrilling ride. The journey begins in the Earth's crust, the layer we walk, build, and live on. This is the planet's skin, a relatively thin layer that makes up just 1% of Earth's total volume. It's composed mostly of basalt and granite, with a thickness that varies quite a bit. On average, the crust is about 25 miles thick, but it can be as thin as 3 miles beneath the ocean's floor, or as thick as 45 miles under mountain ranges. And speaking of the ocean, let's not forget the two types of crust, oceanic and continental. The oceanic crust is thinner and denser, while the continental crust is thicker and less dense. This disparity in composition and thickness is what drives the dynamic movements of tectonic plates, leading to earthquakes and volcanic activity. The crust, as fascinating as it is just the beginning of our journey. Beneath the crust, we find the mantle, a layer of hot, semi-solid rock. This zone, the Earth's thickest layer, extends approximately 1,800 miles downwards. It accounts for about 84% of Earth's volume, a testament to its vastness. The mantle is composed primarily of silicate rocks rich in iron and magnesium. These rocks exist in a unique state due to the immense pressure and heat they endure. They're not entirely solid nor completely liquid, but something in between, a state we refer to as plastic or semi-solid. This semi-solid nature allows the rocks to flow, albeit very slowly. Imagine a candy bar left in the sun. It's not entirely liquid, but given enough time, it will deform and flow. That's a somewhat simplified analogy for the mantle's flow. Now, the mantle isn't just sitting there idly, it's constantly on the move, albeit at a pace of a few centimeters per year. It's this slow, relentless movement that's responsible for the phenomenon we call plate tectonics. The Earth's crust, you see, is broken into several large pieces known as tectonic plates. These plates float on the semi-fluid mantle, and as the mantle moves, so do the plates. This movement isn't without consequence. When plates collide, they can cause earthquakes. When one plate is forced beneath another, it can melt and create magma. This magma can then rise to the surface, causing volcanic eruptions. The mantle, therefore, is not just a layer of rock beneath our feet. It's a dynamic, ever-changing world that plays a critical role in shaping the surface of our planet. Its movements give rise to the continents and ocean basins, the mountains and valleys that we see today. It's the engine that drives the Earth's geology, shaping and reshaping our world in a process that's been ongoing for billions of years. The mantle is a world of constant movement and change, shaping the world we see above. Delving deeper, we reach the outer core, a sea of molten iron and nickel. This vast expanse, extending to a depth of about 2,200 kilometers, is no ordinary sea. It's a swirling, churning, white-hot reservoir of liquid metal, reaching temperatures between 4,000 to 5,000 degrees Celsius. That's hotter than the surface of the sun, folks. The outer core's state of matter is a fascinating aspect to consider. Unlike the solid mantle we just journeyed through, the outer core is liquid. This liquidity results from the extreme heat, which surpasses the melting point of the iron-nickel mix that predominates here. Now imagine a compass needle, it points north, right? But have you ever wondered why? Well, the answer lies in the outer core. The core's rotation, combined with the heat-driven convection currents within this molten sea, generates a dynamo effect. This is essentially a gigantic natural power generator that creates the Earth's magnetic field. This magnetic field is not just for guiding explorers. It's our planet's first line of defense against solar radiation. Without it, life as we know it wouldn't exist. The magnetic field deflects most of the sun's harmful particles, preventing them from stripping away our atmosphere and turning Earth into a barren, lifeless rock. The outer core's role in Earth's geodynamics is not just limited to creating the magnetic field, it also plays a part in plate tectonics, the science of how Earth's crust moves. The heat from the outer core creates convection currents in the overlying mantle, driving the movement of tectonic plates on the Earth's surface. So while it may not be a place we can visit, the outer core is crucial to our existence. It's a roiling, molten sea that powers our magnetic field, protects us from solar radiation, and helps shape the very ground beneath our feet. The outer core, with its molten metals, is a crucial player in Earth's life-supporting system. Finally, at the heart of our planet, we find the inner core, a fascinating sphere of superheated elements. It's the final destination in our journey to the Earth's center. The inner core is primarily composed of iron and nickel, similar to the outer core. However, unlike the outer core, the inner core is solid. You might wonder, how can the inner core be solid when it's hotter than the surface of the sun? The answer lies in the immense pressure that the inner core experiences, a staggering 3 million times the atmospheric pressure at sea level. This pressure is so immense that it forces atoms together despite the scorching temperature, resulting in a solid state. Speaking of temperature, the inner core experiences extremes that are mind-boggling. With temperatures ranging between 7,000 and 9,000 degrees Fahrenheit, it's hotter than the surface of the sun. This extreme heat, combined with the intense pressure, makes the inner core one of the most hostile environments in our solar system. But as hostile as it may be, the inner core is also a place of growth. It's believed to be slowly growing at a rate of about 1 millimeter per year. This growth is due to the gradual freezing of the liquid outer core, which adds to the size of the inner core. The inner core is also believed to play a crucial role in generating Earth's magnetic field. The process, known as the geodynamo, involves the movement of molten iron within the outer core. This movement generates electric currents, which in turn produce the magnetic field. As we delve deeper into the mysteries of the inner core, we're not just learning about the present state of our planet. We're also uncovering clues about Earth's past and making predictions about its future. The inner core, though the most inaccessible part of Earth, holds secrets about our planet's history and future. Our journey to the Earth's core has been a fascinating one, full of surprises and astounding facts. Let's take a moment to marvel at the complexity of our planet as we revisit the highlights of our journey. We began our expedition at the Earth's crust, the thin outer shell that we call home. This layer, although the thinnest, holds the continents, oceans, and all life as we know it. It's a dynamic landscape, constantly reshaped by the processes of weathering and plate tectonics. Our descent continued into the mantle, the thickest layer of the Earth, making up about 85% of the planet's volume. Here we encountered a world of intense heat and pressure, where slow-moving currents of molten rock shape the surface above. It's this layer that's responsible for earthquakes and volcanic eruptions, reminding us of the fiery world that exists beneath our feet. Next, we plunged into the outer core, a sea of molten metal swirling around the planet's center. This layer's ceaseless movement generates the Earth's magnetic field, serving as a cosmic shield that protects us from harmful solar radiation. Without this turbulent molten sea, life as we know it would not exist. Finally, we reached our destination, the inner core. Despite being the hottest part of the Earth, the inner core is a solid ball of iron and nickel due to the immense pressure it's under. This scorching, solid heart of our planet spins faster than the rest of the Earth, driving the dynamo that powers our magnetic field. So, from the familiar surface of the crust to the intense heat and pressure of the core, our journey has revealed the Earth as a complex dynamic system. Each layer plays a crucial role in shaping the world we see and the life it supports. So the next time you walk on the ground, remember, you're treading on just the surface of a complex, ever-changing planet teeming with secrets beneath your feet.